I want to talk about the integral of sine x with respect to x between 0 and pi over 2. Let's first do the integral. Well, the integral of sine x is minus cos x, and putting in the limits 0 to pi over 2, we get minus cos of pi over 2, minus cos of 0. Cos of pi over 2 is 0, cos of 0 is 1, so the result is just 1. What does this mean? Well, the first thing we might do to find that out is to look at the area under the curve sine x between 0 and pi over 2. And that will be the area I have just shaded in red. Well, that's fine, but why should that be actually equal to 1? Is there any reason? Well, let's now think of integration in another way, and remember that if we've got a function of t which is corresponding to the velocity of a particle, then the integral of that function with respect to t and between the limits of a and b, say, will correspond to the displacement of the particle. What this means is that if we can find something which has a velocity sine t between 0 and pi over 2, then the displacement should correspond to 1. Where could we get that? Well, let's look at a unit circle. Now, the coordinates of a point on the unit circle will be cos t sine t, where t is the angle that the radius coming out to that point makes with the x-axis. If we have a particle moving round the unit circle with uniform angular velocity, or constant angular velocity, of say 1, what would the vertical and horizontal components of that velocity be? Well, they'd be the derivatives of cos t and sine t respectively. So the vertical component would be cos t, and the horizontal component would be minus sine t. So we're saying that as a particle moves around the unit circle with constant angular velocity, the horizontal component of that particle would be moving backwards and forwards along the x-axis with velocity minus sine t. And we're saying that as it goes a quarter of the way round the circle, between 0 and pi over 2, then it will have covered 1 unit of distance, which is the radius of the circle, between 1 and 0. Let's see how that will work with an animation. The animation will show us a particle going around the unit circle with constant angular velocity, and at the same time its horizontal component of that particle. The horizontal component is the red dot, the particle is the black dot. And as you can see, as the black dot goes round 1/4 turn, the red dot covers 1 unit, the radius of the circle. The velocity of the red dot will be minus sine t, and of course the black dot has uniform angular velocity as it goes round the circle. We can add in a vertical component, shown here by the blue dot, and the velocity of the blue dot is cos t. Motion from a constant angular velocity around a circle like this is called simple harmonic motion. The blue and the red dots are both showing simple harmonic motion.